One of the things we found today in class on Monday was something that we've talked about before, but just we reiterated that if we could factor an equation, in this case we have a trinomial, that here I could say this is x plus 4, x plus 2 equals y. And then if I thought about when this was set equal to 0, this is going to tell me, because y is equal to 0, that these are going to be my x-intercepts. Sorry for the chicken scratch, but that x is equal to -4 or -2 when y is equal to 0. So on a graph, that would mean that you're, let's see, here at -2 and here at -4, and those are your two x-intercepts. We touched upon the fact that this is a positive. There's a positive coefficient here of 1, so that means I know that it's going to open up, which was pretty great, and that the vertex was going to be the minimum value of the parabola. We saw this in 8z today. Danny Little asked a question about what would happen if we factored and there were more than two pieces. So what would happen with the graph with that, which was awesome. So we had x times x squared minus 1, and then we broke that into difference of two squares. So we saw x times x plus 1 times x minus 1. So then the question was, well, if that's what happens, what does that mean in terms of our x-intercepts? And so we said that x had to be, when y was equal to 0, that x could be 0 or -1 or 1. So then it was, the whole idea was brought up about what could that possibly do to our graph. So we no longer could have just two x-intercepts, we'd have three x-intercepts. So if you're interested, which I'm assuming you will be, you can take your graphing calculator or GeoGebra and plug this original equation in and see just what happens, because you won't have a parabola anymore, which is pretty amazing. Then what we did was we took all of this, all these different pieces, and brought it together back to the graph to see if we could see any other relationships, because there's some pretty ridiculous ones with equations in their graphs. So we can factor this if you want, and we get x plus 3, x minus 1, and then we know that from that x is equal to 1 or -3 in terms of the x-intercepts. So we know that we're at x is 1, or x is at 1, 2, -3 here. We know that here, because of this x squared being positive, we know that it opens up. But we also know that parabolas have this ridiculous amount of symmetry, so we know that whatever is on one side of the parabola is going to be on the other. So we looked at here that from one x-intercept to the other, there are 4 spots apart, so that we knew that 2 spots in on either direction, there would be the vertex, and we knew it was down below again because this is a positive value. So then we said it goes up like this and up like this. And then we looked at a couple other situations and found that we wanted to be able to really generalize this. So we saw that the x-coordinate of the vertex was in between 1 and -3, or at -1. So we know the x-coordinate is -1. And then after we looked at that a little bit more, we said, well, wait a second, does that have anything to do with this? And it does. It's going to have more to do with it later this week. But for now, we're saying, Molly found it, saw it in 8z, that half of this 2, she took this and divided it by -2. And that's how she got this x-coordinate of the vertex. And we saw that in a couple other examples and saw for sure that's exactly what happened. And I just want to point out one more thing to you here, is that in order to find now the y-coordinate of the vertex, because we only know the x-coordinate of the vertex, is that we can plug it into either the factored form, or we can plug it into the simplified form. I'm going to plug it into this one because it's just smaller numbers for me, easier for me to do. So I'd have -1 plus 3 times -1 minus 1. So we'd get 2 times -2 or -4. So our vertex is at -1, -4. And we did that really from knowing, again, that these were our x-intercepts, and that this was, if I took half of this found the opposite of half of that, then that would give us the x-coordinate of the vertex. For now, again, we'll change a little bit later.